Hi, welcome to another physics video podcast. We're going to do a set on mechanics now, so this is mechanics 1. And we're just going to start off with the most fundamental thing in this area, which is vectors and scalars. All the quantities in the world, everything we measure, is either a vector quantity or a scalar quantity. Scalar quantities are the more straightforward. Things like temperature and mass are our classic examples of scalar quantities. They only have an amount. There is no direction associated with them at all. Vector quantities, on the other hand, do have a direction associated with them. So force would be a great example of a vector quantity. Because to really describe a force, not only have you got to say how many newtons are acting, but in what the direction they're acting as well. Other vector quantities that you should be aware of are velocity, displacement, electric field strength, gravitational field strength, that sort of thing. There are a few important pairs of quantities that by convention we've split. So we have speed and velocity, distance and displacement. Speed simply means how fast you're going, how many meters you travel per second. It makes no reference to the direction. Velocity is the vector equivalent. It tells us not only how fast you're going but the direction. So it's the difference between going 10 meters per second and 10 meters per second north. Distance is the scalar quantity. It's simply how far you are away from something. Displacement is the distance and the direction. One of the big differences between vector and scalar quantities is the maths that operates on them. So if we take a simple example, if we have a 5 kg pile of sand and we have another pile of sand with mass 3 kg and we get a shovel and we mix them up, no one would dispute the fact that the result is a pile of sand with mass 8 kilograms. Vectors, it's a bit more complicated than that. If we imagine a block and we imagine applying a couple of forces to it, we might apply a force of 7 newtons in this direction, and we might use another method to apply 5 newtons to the block, and obviously that would result in a resultant force of 13 newtons in that direction. However, that's not the only way that vectors can work. Because it could be that we apply 7 newtons from one side and 5 newtons from the other side, and the resultant now is simply 2 newtons in that direction. We have to take in the direction into account, and we'll look in the next video podcast at how we deal with vectors that have an angle between them. Thank you.